Alright, so today we are going to talk about comparing and ordering rational numbers. So we already looked at comparing and ordering integers. Now we're going to take it a step further by looking at fractions, decimals, and percents. So just like before, we're going to complete the inequalities by filling in each circle with the less than, greater than, or equal to sign to make it a true statement. So what is a rational number? Well, a rational number is any number that can be written as a fraction. So almost every single number is a rational number. The only things that aren't are decimals that go on and on and on forever without repeating. So terminating decimals, decimals that end, and then those repeating decimals are also rational numbers. So here are the steps to comparing rational numbers. So step one is just kind of some questions you're asking yourself to see if you can compare without having to do any conversions. So the first thing is you're going to look at the number and you're going to say, are the signs different? If you have one number that's positive and one number that's negative, that should be easy to compare because the positive is always going to be greater than a negative. But then you can also ask yourself, are the whole numbers different? So if you have 5 and 3, that's going to be easy to compare. We don't need to look at the decimal part or the fraction part. So once we've done that, we're going to move on to step 2, which is, if those signs and or the whole numbers are the same, then we need to turn every number into a decimal. So you really can do any of those conversions, but we're going to do decimal for every single one because we already gave you that conversion chart and we think it's going to be a lot easier to compare that way. So once we do that, we're going to look at those decimals and then add any zeros if necessary to the right of the last digit so that there are the same number of decimal places in each number. And after that, then we're going to compare the number after the decimal point. So let's look at a couple examples. So for number 1, we've got 87 hundredths and 8 tenths. So the first step is to make it into a decimal. These both are already decimals, so I don't need to worry about that. But now I need to look and see if I need to add any zeros to make them have the same number of decimal points. So looking at here, I have 2 decimal points there. So I want to make sure that I have 2 decimal points there. So what I'm going to do is I'm going to add a 0 so that now they both have 2 numbers after the decimal point. And now I can just look at this part, 87 and 80. Since it's positives, 87 is bigger than 80, so 87 hundredths is greater than 8 tenths, or 80 hundredths. The second example, we've got 5 eighths and 7 eighths. So first thing I'm looking at, is one of them positive and negative? Nope, they're both positive. I'm looking at the whole number. There's no whole number with it, which means they both have a whole number of 0. So I have to actually compare them by converting them into decimals. So either we can use our calculator and do 5 divided by 8 on the calculator to show us the conversion, or we can use our conversion chart. On the conversion chart, you're going to see that 5 eighths is 0.625, okay? And then 7 twelfths, that's not actually on our conversion chart, so I'm going to divide that, and 7 divided by 12 gives me 0.583, okay? So, we know they are both positive, we know they have the same whole number value, so now we're going to look at the decimal values. This number has 3 numbers after the decimal point. This number also has 3 numbers after the decimal point. So I'm just going to compare the 2 numbers. 625 is bigger than 583, so 5 eighths is greater than 7 twelfths. Example 3, we've got negative 2/3 and negative 5/6. So again, first I'm going to look, do they have opposite signs? Nope, they're both negatives. Then I'm going to look at the whole numbers. There's no whole number with it, which means they both have the same whole number of 0. So I need to convert these to decimals in order to compare. So we've got negative 2/3. Again, I can either plug this into the calculator and do 2 divided by 3, or I can use my conversion chart, and I'm going to see that I get 0.6 repeating. So I'm going to put that repeating bar above it. And then we have 5/6, negative 5/6. When I plug that into the calculator, or if I use my conversion chart, I see that I get negative 0.83 with the repeating sign. Now we both have 2 decimals. We need to make sure they have the same number of decimal numbers after the decimal. We have 1 here and we have 2 there. So what I'm going to do is I'm going to add a number here. Normally we would add 0, but since this is a repeating digit, it's not followed by a 0, it's followed by another 6. Now I can compare these two numbers. We've got 66 and 83. Normally, if we were talking about positives, 66 is smaller than 83. But remember that negatives work in the opposite way. A smaller negative is actually a bigger number, and a bigger negative is actually a smaller number. So, 66, again, is normally smaller than 83, but since it's negatives, it's the reverse, it's actually bigger than, it's greater than. So negative 2/3 is greater than negative 5/6. Okay, a couple more examples here. We've got 2 and 5/6 and 3 and 3/12. So first thing I'm looking at is, are they opposite signs? They're both positive, so we can't use that. So now the next thing we're looking at is, do they have the same whole number? This has a whole number of 2, this has a whole number of 3. So they're different. I'm actually going to highlight just the whole number parts, and I can ignore the fractional parts. All I need to look at is the whole number. So I'm looking at 2 and 3, positive 2 and positive 3. And I know that 2 is smaller than 3, so that tells me that 2 and 5/6 is smaller than 3 and 3/12. Example 5. Again, looking, are they opposite signs? Nope, they're both positive, so I'm looking at the whole number value. Do they have different whole numbers? Nope, they have the same whole numbers, so now I'm looking at the decimal values. Right now when I look at it, it looks like they're exactly the same. But I notice that this has the bar above it, which again says that it's a repeating decimal. So what I'm going to do is I'm going to rewrite these decimals below. And I'm going to remember that if it's a repeating decimal, it's a 3 followed not by a 0, but by another 3. Versus this 3, since it doesn't have the repeating bar, is followed by a 0. So now I'm comparing 33 to 30. And I know 33 is bigger than 30, so 3/10 repeating is greater than 3/10. Then here, for number 6. Again, I'm looking at first, do they have opposite signs? Nope, they're both negatives. Then I'm looking at the whole number part. They have the same whole number. So I do need to make sure that they're both decimals so that I can compare. They are both decimals. This one has 2 numbers after the decimal point. This one has 3 numbers after the decimal point. So I need to rewrite this so that they have the same number of digits after the decimal. So I need to add a 0. So I have 3 numbers after the decimal point here and 3 numbers after there. So now I'm going to compare 730 to 734. If we were talking about positive numbers, 730 is smaller than 734. But we're talking about negatives, so it goes in the reverse way. A smaller negative is actually a bigger number. So negative 2.73 or negative 2 and 73/100 is actually greater than negative 2 and 734 thousandths. Okay, so a couple more examples up a little bit on the page. So this one, we've got 3/4 compared to 7/10, 0.7. Okay, are they opposite signs? No, they're both positives. Do they have different whole numbers? Well, this one, even though there's nothing written there, they have the same whole number of 0. So I need to convert so that they're both decimals. This one's already a decimal, so I'm going to convert 3/4 to a decimal. Maybe you know that one by heart. Maybe you're going to plug in the calculator, 3 divided by 4, or you can use your conversion chart, and you're going to see that 3/4 is equivalent to 75/100. So now I'm comparing two decimals. I need to make sure that they have the same number of digits after the decimal point. This number has 2, so I need to have 2 here, so I'm going to add in a 0. Now I'm comparing 75 to 70. 70 is bigger than or greater than 70, so 3/4 is greater than 7/10. Number 5, first thing I'm looking at, do they have opposite signs? For the first time, yes, they do. I'm going to write this is a negative, this is a positive. We should know a negative is always smaller or less than a positive. So I didn't have to do any computation there. Number 6, I'm looking at, do they have opposite signs? Nope, they're both negatives. Next thing you're looking at, do they have different whole numbers? Well, if I look at this one, the whole number here is -5 and the whole number here is -3. So I actually don't have to worry about the decimal part, I can just look at the whole numbers. Again, normally 5 would be greater than 3, but since we're working with negatives, it goes in the opposite direction. -5 would actually be smaller than or less than -3. Number 10, again, do they have opposite signs? Nope, they're both negatives. Do they have different whole numbers? Well, right now it might be hard to see, so I'm actually going to convert it into a decimal right away. This one's already a decimal. To turn a percent into a decimal, I'm ignoring the percent sign, adding the decimal point, and moving it twice to the left. Once, twice. So over here I have -6 and 5/10. Over here I have -6 and 50/100. So they're both decimals. This one on the right has 2 numbers after the decimal, so I need to add a 0 here, so that one has 2 numbers after the decimal. Now I'm comparing. They've got the same whole number. If I look at the decimals, 50 and 50, they are the same, so they are equal to each other. Number 11, are they opposite signs? Nope. Are they the same or different? They are the same for the whole numbers, so we need to look at the decimal or fraction part. I'm going to convert just this fractional part, because I know that their whole numbers are the same. I know that the whole number is 5. So I'm just worried about converting this part right here. If I use my conversion chart, I'm going to see that 2/5 is equivalent to 4/10, or 0.4. Again, now when I compare, this has 2 numbers after the decimal point, so I need 2 numbers after the decimal point here. So I'm going to add a 0. 40 is smaller than 41, so it is less than. Okay? And then last one, just comparing here. Do they have opposite signs? Nope, they're both negatives. Do they have different whole numbers? It might be tricky to see here, but you'll realize the whole number in this one is -1. Since there's no whole number written there, it's really 0. So I can ignore that decimal part and that fraction part, and I'm just comparing -1 and 0. Okay? 0 is kind of our middle point between negatives and positives, and this negative is less than 0. So we're going to pause here for a minute, and we're going to move on to a